Welcome, everyone. My name's Hallie Rosen, and I'm the program director here at the Chicago Architecture Center. I'm so glad that all of you are here today. We're happy to be hosting this class for AIA. The last event we worked with AIA with was our holiday party, which I think was a little livelier probably, but we're not serving drinks this afternoon, but I know it's going to be an informative afternoon. So very important, if you want to be on Wi-Fi, you should look for Chicago Architecture Center guest, and the code is welcome to CAC, all lowercase, no spaces. So it's Chicago Architecture Center guest, and then welcome to CAC is the password. So I don't know if you've already seen our exhibit Energy Revolution, but it is right in the center on your way out, or if you had a chance to look at it on your way in. I want to encourage you to look at it. I know that Grant really wanted to have this class here so he could connect the exhibit to the information presented. Tomorrow is the last day of the exhibit, so this is really your great opportunity. So I hope that you'll join us and visit the center on your way out. I also want to mention that February 1st to the 5th, we're hosting the Architecture and Design Film Festival here, because where the Energy Revolution exhibit is right now is going to be deinstalled, and that's where we're actually hosting the film festival, in this room and in that room. So it will be 5 days of films on architecture and design, and I think it'll be a wonderful experience. So just go to architecture.org to get more information and to choose the films you want to see. And then in April, there will be a new exhibit. It's about mass timber. That's all I'll tell you about it right now, because we're really in formation, but lots for you to keep coming back, and hopefully there'll be another holiday party in December. So without further ado, I want to invite Katie Kaluzny to come up and introduce our speaker. And I know she's not a stranger to this audience. She's with the Illinois Green Alliance.
Thank you, Hallie. Do I sound okay in the back? Awesome. Thank you guys all for being here today on this wonderful Monday afternoon, right after the holidays. I'm Katie Kaluzny, as Hallie mentioned. I'm Associate Director at Illinois Green Alliance. I'm excited to be moderating today's panel and partnering with AIA Chicago on this great event. I want to make sure that we talk first about the fact that this counts for AIA credits. So to my friends online on Zoom and to those in the audience, I wanted to make sure that you are aware that this is AIA approved for credits, and that these are the learning objectives that we're about to embark on today. Today's session is going to be, you're going to learn a lot about the code. You're going to learn a lot about what that means for architects and some things to pay attention to. There's going to be a lot of times for Q&A, but also there's some interactive components. So you can't just sit back and relax. You have to be ready to participate actively, interact with your phone, and Grant's going to show us a little bit about that when he gets started with his slides, but I just wanted to make sure that you had your mindset ready to be interactive and also learning at the same time. We have some really great speakers here today, and I've got some bios to read about them. One of them, I'm not going to read my own bio. I work at Illinois Green. You guys know that already. But the first person we have that's going to speak today is Grant Ullrich, and Grant is the Managing Deputy Commissioner at the Department of Buildings for the City of Chicago. He led the charge within the department to develop and introduce the Energy Transformation Code that we're here to talk about today. Prior to his time in the Buildings Department, Grant also served in the Legal Department with the City of Chicago, and he's a member of AIA, has both an architecture and a law background, which is perfect for the Buildings Department and this conversation. Our second speaker today is Emily Purcell. Emily is the Sustainability Lead at Solomon Cordwell Buenz, or SCB. She's also actively involved in coordinating programming for the Carbon Leadership Forum Chicago Hub, which I'm sure has some great programming coming up this year. And prior to her time at SCB, Emily spent a long time working at GBCI as a lead certification reviewer and at USGBC. And she also has a background in urban planning and policy. So very excited to have Emily here today to talk about some of the ins and outs of the code that she's looked at that are specific to architects. And then finally, we have Saagar Patel. He's not going to present today, but he's going to be here for all of the hard questions that you guys ask at the end. Saagar is the Operations Director for Commissioning and Energy at ESD, and he currently serves on the State Energy Code Advisory Council and is actively involved with ASHRAE, Illinois. And prior to his time at ESD, he was the Senior Engineer at Aero Building Solutions and spent some time doing awesome work at Gobi and Primera Engineers. And so you have a great panel here with you today. I'm excited to get started and hear more. All four of us spent time on the City of Chicago's Building Decarbonization Working Group, where we got to spend a lot of time talking about things like this and codes, and I'm really excited to see where this has come so far and hear your questions at the end as we keep going. So without further ado, I'm going to turn it over to Grant Ullrich to kick us off for today.
So good afternoon, everyone. Thank you. Let me just move something out of the way so I can see the notes. And I'm Managing Deputy Commissioner of the Department of Buildings, as Katie said. I really want to say thank you to the Chicago Architecture Center for hosting us here today, and also to AIA Chicago and Illinois Green Alliance for helping us put this program together. Also, thank you to all of you here in the room, out there virtually, and those who are going to be watching the recording later. So we really appreciate your participation in making the code work. So as Katie mentioned, we're going to use something called Slido for some audience participation and to get audience questions. We'll also have the opportunity for people in the room to ask audience questions with a mic. But Slido is the tool, so you can take that QR code or use the URL. If you're in the room, you can use smartphone devices. If you're watching virtually, you can join with a smartphone, or you can do it on the same device you're watching us on. So we're here today to talk about the 2022 Chicago Energy Transformation Code. But before I get started with that, I just want to point out that the Energy Transformation Code is just one piece in Mayor Lightfoot and the City of Chicago's commitment to address the climate crisis with a focus on equity. And there's been a lot of activity in the last 3.5 years since the last code was passed and took effect. So we're going to try and get you up to speed with where we're at today. We understand there's a lot going on. It's hard to keep track of. And so that's why we want to check in. The Department of Buildings is really proud to play a major role in decarbonization of our buildings. That's part of the larger strategy. There's decarbonization of transportation and industry and other things that aren't as directly related to buildings, but buildings are a big contributor to the carbon footprint in Chicago. It's been decarbonization and energy issues have been an important focus of our ongoing code modernization effort and will continue to be. And we understand with all of our code efforts, we have to be working in partnership with the design and building communities who are actually out there doing the work. That's why we're here to present today. That's why we partner with the organizations AIA Chicago, Illinois Green Alliance, and others to really get educational and informational programs out there to the audiences that matter most. So thank you again for being here today. And then just an overview of what I'm going to cover before Emily comes up here and gets into the details of some things. I'm going to cover the sort of basic organization and intent of the Chicago Energy Transformation Code, highlight some key changes from the last Chicago Energy Conservation Code that either come from the change in the base code, the 2018 to 2021 International Energy Conservation Code, or the local amendments, both the state and city. Discuss how you can and should determine and document compliance of your projects with the Energy Transformation Code, and then talk about some additional resources. We have a short program today, so we're not going to cover everything, but point you to some additional resources that are out there. So the Chicago Energy Transformation Code is an integrated part of the overall Chicago construction codes and works together with the Chicago zoning ordinance. So it can't be read on its own. It's important to think of it as just part of the Chicago construction codes. Right now, the ordinance adopting the code, so the local amendments is available. We are working closely with ICC, the International Code Council, to publish that consolidated book like we did last time. Like everything else in the world, supply chains are a little different right now. So in the publishing world, there is a little bit of a delay in getting that out there, but we're expecting in the next maybe in about a month to two, that will be out there both in print and electronic formats, the Consolidated Chicago Energy Transformation Code. We know people are looking for that. The Energy Transformation Code, like the Model Energy Code and prior Chicago energy codes, is broken into two parts, residential and commercial. The residential part covers non-transient residential buildings, so group R2, R3, R4, and R5 occupancies, up to 4 stories. And just to note, that's 4 stories in Chicago. The model code and the rest of Illinois is 3 stories. So that's a Chicago difference to keep in mind. The other part of the code is called commercial provisions or commercial buildings, but it's really easier to think about that as everything else. So that includes both all non-residential projects, all non-residential buildings, but also transient residential group R1 hotels, and also taller residential buildings, so a high-rise apartment building. Each part of the code is broken into 7 chapters in the Chicago Code. Chapter 6 is Chicago specific, that's inserted by us, and then we call the reference standards at the end their own chapter. Unlike the model code, most of the administrative provisions in Chicago are in the Chicago Construction Code's administrative provisions, so Title 14A of the municipal code or Chicago construction codes, but there is a little bit there. We'll talk about the intent statement that's in Chapter 1. Chapter 2 has definitions like most model codes. Those are important for understanding defined terms. But the core requirements are really when you get into Chapter 4 and then supplemented by modifications for existing buildings found in Chapter 5. And as I said, those Chicago specific requirements that really are what lead the code to be called energy transformation, that's Chapter 6. So there are very similar intent statements at the beginning of Chapter 1 of each part. I'm not going to expect you to read it. We'll break it down. So the intent statement contains some important concepts. First, the energy code is about regulating primarily design and construction, not operations, to achieve 2 objectives. One is about energy efficiency and the other is about reducing carbon emissions of buildings over their useful life. Second, the code is intended to be flexible to the extent that flexibility is going to further these 2 objectives. And finally, the energy code can't override requirements in other codes or laws. So that flexibility is within the sort of code itself. And if there are conflicts or other provisions, we have to work through those in some other way. That statement about flexibility doesn't get you all the way there. One question that I get a lot is, why is this being called the Energy Transformation Code as opposed to the energy conservation codes like the model codes and earlier Chicago codes? So really the answer is that this code, like the other code, starts with a baseline of reducing energy usage, conserving energy. That's an important first step. But then it adds on provisions that help us move towards a cleaner energy future with preparations for future electrification and then solar installation on new buildings. So preparing for that to get buildings that are built or remodeled in a major way under this code ready for that clean energy future, because we know that they're going to be part of Chicago's building stock for decades. Because in Chicago, most of the work that we issue permits for is work in existing buildings, not new construction. Chapter 5 of both parts of the code is very important. And at a high level, Chapter 5 is like the Chicago Building Rehabilitation Code in that it has tiered requirements for different types of rehabilitation work or work in existing buildings. Repairs have the fewest requirements. Alterations are somewhat in the middle. They have modified requirements. And then additions and changes of use, and specifically changes of use that increase the energy usage, either electricity or fossil fuel energy usage, are required to come closest to the standards for new construction. So now on to topic 2 that I'm going to cover, highlighting the most important changes from 2019 to the 2022 Energy Transformation Code. Those code changes come from both the change in the underlying model code from the 2018 to the 2021 editions, and also local amendments. So Chicago looked to the proposed Illinois code amendments. Illinois has a process every 3 years where they look at the latest model code and have public committees that study that, accept proposals. So we looked at what those Illinois committees were recommending to the Capital Development Board, looked at proposals they accepted and also ones they did not. and decided what we want to do for Chicago. We also had some other conversations with stakeholders in Chicago about what was going to do. So the Illinois code is still in progress. I think, are moving forward early this year with a new proposal that we expect will probably become binding as the Illinois code later this spring. But we have been watching that process, and from where it's at in the state process, we expect that Chicago's code will likely exceed, but at least be equal to that state code as required. So going through, again, the code is broken into residential and commercial. We're going to start with the residential and then move on to the everything else. So specifically for those residential buildings, the residential provisions have long been focused on achieving energy efficiency through the building envelope, so making that envelope tighter and more efficient. And for our climate zone, in the latest edition of the model code, those requirements have gotten stricter. So requirements for air leakage and duct testing also became stricter under this code. And sort of specifically, some requirements haven't changed, other requirements have. So again, the requirements for R values for walls and roofs, as well as the corresponding U factors, have become more stringent. They're going to be more challenging to meet. That means a design that was a project that was designed and met the bare minimum envelope requirements of the code before November 1st now no longer meets the code for permit applications that start November 1st, 2022 or later. We've seen some projects, run into that, be aware of that, but other projects, were above code or knew that those changes were coming. As noted, some of the testing and duct sealing requirements have been strengthened, but low-rise residential projects, the things that covered by the residential code, don't have the most complex mechanical systems to begin with. So the changes here are similarly less complex than we see on the commercial side. For lighting and electrical requirements, I think the big things to know for residential. So now 100% of the permanent lighting has to be high efficacy, which usually means LED. And most interior lighting is going to require either dimmers or occupant sensors. For multifamily buildings with outdoor parking areas, the code now references the commercial provisions for the sort of lighting standards for that outdoor parking. So setting a sort of level playing field for those buildings that are going to have large outdoor parking areas. And then again, the energy code has several compliance paths as part of its attempt to be flexible. So one of those is called the Energy Rating Index, or ERI compliance alternative. We don't see a lot of projects choosing to use that here in Chicago or Illinois, but in other parts of the country, it is widely used for residential compliance. So maybe we'll see that. But just to note, the target for ERI, if you are using that sort of point scoring evaluation method, is getting stricter like the rest of the code, about a 5% reduction in energy usage. And then another feature that's new from the model code on the residential side. So the commercial side has long had this provision that require you to pick from a menu of additional efficiency options. So you have to get a minimum score on the commercial side based on your project type. On the residential side, there's now a menu of 5 options, and you have to pick 2 of those 5 options from the menu. Some of them are easier than others, so I have a guess about what a lot of projects are going to choose, but you do get to choose any 2 of those 5. And then in terms of the proposed Illinois amendments and Chicago amendments, so one thing that came from the state code and we adopted, incorporated into ours from the state proposal, is recognizing the FIAS 2021 certification for a project as really exceeding our code. So if you are choosing to do the FIAS 2021 certification, you're just going to tell us that, and the rest of the energy code steps out of the way for the most part. Similarly, in Chicago, not in the state code proposal, but for Chicago, we're similarly recognizing something called the National Green Building Standard, similar a certification program. If you comply at the gold or the emerald levels, which are the top 2 levels of that certification program, you can skip many of the prescriptive requirements of the Chicago code because you're going to be going through their process, which for both of those programs involves sort of a pre-design review with the certifier and then also some post-construction verification. Another sort of Chicago unique provision that went into effect when this code took effect November 1st is new gas lighting is prohibited. So again, it's sort of decorative, non-functional, and that's sort of the beginning of our energy transformation, where we're starting to have code provisions that put their finger on that fuel source, what's going on. Some differences from the Illinois proposals that are out there. Chicago has had some re-roofing language in, I think, the last 2 editions of our code that are a little bit different for re-roofing flat, low-sloped roofs. Those are continuing to have those sort of allowances for recognizing that there's existing sills and flashing conditions that can't really be changed as part of a re-roofing project. Masonry wall insulation exceptions for certain older multi-wide load-bearing masonry exterior walls. That was in a code memo the department issued in 2017. Now it's in the code. Some adjustments to the Illinois whole house ventilation provisions to better line up with our mechanical code. And then recognizing in Chicago, we have more cold form metal construction than other places in the country, and recognizing that some of those provisions in the 2021 code and earlier editions were confusing, and the industry had proposals to clean that up in the 2024 model code. Those 2024 proposals, we worked with AISC and other industry groups to get those into our code for now. Additional Chicago provisions. So these are the energy transformation provisions. These are the ones that apply to projects with permit applications started since the beginning of this month, the beginning of this year. So electrification readiness for residences. So new residences, so new apartments, new houses that have individual gas-fired appliances must be built with the electrical capacity and wiring for future electrification of those appliances that are, individual appliances for hot water, clothes drying, and cooking within those units. It doesn't apply to shared systems if you have a building that still has shared hot water systems or things like that. Solar ready zone is a requirement that in buildings that are 4 stories, it doesn't apply to 3-story buildings in the residential portion of the code. If you are 4 stories, which again is the maximum you can be, and you have a 7,500 square foot footprint, you're going to have to structurally reinforce that roof for future installation of solar potentially. And Emily has some more detailed slides coming up to go into all of these with some great examples. And then there is a provision for enhanced thermal break requirements for some weaknesses in building envelopes, especially where there's penetrations of the building envelope to connect parapet walls or exterior balconies. So moving on to the commercial provisions, and the commercial code has even more compliance paths than the residential side. So again, a lot of these are for the prescriptive provisions. There's still the choice to use ASHRAE 90.1. Chicago doesn't really amend that. So if you're using the 90.1 path, you're using it outright. And then within 90.1, there's different routes. But if you are using the prescriptive routes in the IECC based or CETC based provisions, there's going to be some increased requirements for insulation, performance, as well as solar heat gain coefficients, again, tightening up that building envelope just like we saw on the commercial side, and some expanded requirements for testing that envelope to make sure it's working. On the commercial side, we didn't see this on the residential side. There's some additional provisions about public openings to control sort of heat loss through those openings, requiring things like vestibules or air curtains or revolving doors to limit that heat loss. On the mechanical side, some updated efficiency requirements reflecting that certain types of mechanical equipment, the industry is able to design more efficient equipment. So those requirements have tightened in line with sort of what is being out there. The code pulls people along to use newer, better equipment for newly built things. There's some refinement of language around energy recovery ventilation systems. So we have those. We have language that's been added in the last year or two in our mechanical code to try and facilitate those. Those are still new and challenging for some projects. So we're still working through that. But we do see people wanting to use that, recapture that heat from exhaust air and add it to outdoor air. And we want to support that. And then similarly, fan equipment has become more efficient. So the efficiency requirements have strengthened. On the lighting side and lighting and power side, again, looking at where the industry is at, where technology is at, that efficacy requirement has strengthened, and the sort of lighting power density allowances have decreased, so you can achieve the same level of illumination that you need for functional purposes using less power. There's some provisions about lighting for plant growth, as we have new crops that like to grow indoors, and Illinois has some specific things that they amended there. And then the provisions about receptacle control and some occupancy controls really have been lined up between the ASHRAE and the IECC provisions. So there's sort of less justification to use those provisions for choosing between which compliance route you're going to take. On the commercial side, again, several code additions, they've had this additional energy efficiency options where you have to pick from a menu and achieve a certain point score. That section was getting a little confusing, so it's been reorganized and cleaned up. Some new choices were added in the model code, some additional choices to get your minimum score that you need. And then Illinois added some more, which we incorporated. So in terms of the base prescriptive requirements, another thing that was different in the model IECC versus ASHRAE 90.1. ASHRAE 90.1 in its prescriptive requirements had some provisions about fenestration and orientation of the building. Again, to take away the incentive between those two in the Illinois proposals, it took that ASHRAE language and put a version of it into the base energy code. We're doing the same thing. So again, if you are using the prescriptive route of either code, you are going to have to make some choices about the orientation of your building, and there may be some limits on the area of glazing. You can always use the sort of modeling performance approaches in either code to address that more creatively. Lighting for plant growth and maintenance, as I said, we have some crops in Illinois that are newly legal. People like to grow them indoors, and that can be a very energy intensive use. So there are some code limitations on the power usage for those specific types of operations. And then one thing that, again, I think there's some confusion and questions on out there, both in the Illinois proposed language that's not yet in effect, but also in our code, there's some language about grid integrated controls, but really that's in that additional efficiency packages section. It's an option to get a passing score, but there is no requirement for grid integrated controls. We know that's a new technology, especially in Illinois. They've had it on the coasts, especially in California, for a little while. But that technology isn't necessarily ready here yet. Our utilities aren't necessarily ready to accommodate it yet. But that language is in the code for projects that can make that work. But it's an optional path to get efficiency points, not some requirement for a new technology that no one knows how to manufacture. Similar to the residential side, on the commercial side, Chicago will accept certified FIAS 2021 or National Green Building Standard 2020 Gold or Emerald buildings as an alternative compliance path. That's a little bit different than the Illinois proposal, which only recognized FIAS on the residential side. We're recognizing it for commercial buildings too. FIAS can be used for a range of building types. National Green Building Standard can be used for sort of larger residential projects. And similarly to the residential side, a prohibition on natural gas or gas lighting. Similar modifications, again, around low slope re-roofing, masonry wall insulation, and cold form steel envelope requirements. So those are sort of similar Chicago modifications to both parts of the code. And then when we get into the energy transformation pieces, again, it's very similar for the residential buildings that are large enough that they fall under the commercial provisions of the code. Similarly, the electrification ready requirements, a requirement that I guess applies on both sides, but I'll mention here, if there are common areas that have sort of domestic cooking equipment, if there's a community room, common room that has cooking facilities, those similarly have to be electrification ready if they are gas. On this side, the solar ready is a little bit broader for roofs. This is getting roofs from 1 story up to 60 feet in building height. Over 60 feet in building height, there's some additional sort of factors that make it hard to have a prescriptive requirement. So those buildings are not covered, but 1 story to 60 feet in building height, if you have a footprint of 7,500 square feet or more, and you have available roof area of a flat roof, you have to make that roof solar ready in terms of structural reinforcement, and then having a path in the building for future conduit to get from a solar installation to the electrical equipment. And then similarly, very similar language about thermal breaks and for parapets and exterior balconies. So topic 3 that I want to cover is briefly how to determine and then document compliance with this code for both permitting and construction. So at a high level, we require all projects to file a 1-page energy code compliance statement. That's been, I think, the last 3 cycles of code, how we have been documenting things. So those PDF forms are out there. They've been out there since the end of October, right before this code took effect. We used to have something called registered energy professionals. We got away from that. Now any licensed design professional in Illinois can fill out these forms for a project and certify compliance. Form 408C and 408R are the current form numbers. We're excited that in the next month or 2, we're going to move away from those PDF forms to a sort of an online assisted filling out the form tool. It's going to be about the same amount of questions, but it's going to, I think, be a more interactive experience, and you're not going to be able to put in contradictory answers. Many small and medium projects we know use the ComCheck and ResCheck tools that are out there from the Department of Energy. Again, if you're doing that in Chicago, you have to be aware of the Chicago amendments. We're very excited that in partnership with the Department of Energy, I think by the end of this month is the goal. The Chicago 2022 Energy Transformation Code is going to be a drop-down choice in ResCheck and ComCheck. So they are incorporating all of the Chicago differences, and ResCheck and ComCheck will capture that, and you will not have to remember in the back of your head the Chicago differences from the base 2021 IECC. So I think that's an exciting thing, and we're hopeful going forward we'll be able to do that with every code cycle. And then, there are ways to comply without using ResCheck and ComCheck. Some bigger projects are using energy modeling. Smaller projects don't need to do that. They can go through the prescriptive requirements and write a letter. ResCheck and ComCheck are a tool for that sort of mid-range of project, but there are 8 compliance paths we think about on the residential side and about 11 on the commercial side. So we went through and on our website at chicago.gov/energy code, we now have these sort of compliance method summaries that highlight, how you're going to comply. If you choose that method, what we're going to expect you to upload as part of your building permit application, and then what obligations come in terms of the construction phase, in terms of testing and verification, and how you might document that. So we went through and for those 19 different compliance paths that you can choose in the choose your own adventure code, we have these nice little summaries for people. So hopefully that's a good tool that's out there. Again, one of the things that you're signing off on our compliance statement is that you've informed your clients of the sort of construction phase verification and testing requirements. So again, you can use this page as a resource to tell them, copy and paste exactly what those are going to be based on the compliance path that you're choosing at the permitting stage. And then for the final topic that I want to highlight before I turn this over to Emily, as I've already mentioned, chicago.gov/energy code is our sort of landing page for resources specific to our code. We'll have a link to this video there probably within a week, as soon as we can get it finalized and posted. But it also has summaries of the compliance paths that we talked about. It has summaries of the Chicago specific requirements that are in chapter 6 of both parts. So those are some nice resources that we started with. And I think as we hear from you that there are different resources that we need, we'll likely be adding more. Again, chicago.gov/energy code. The other resource that's out there, continues to be out there as a really good resource, is the University of Illinois Smart Energy Design Assistance Center, or CDAC if you don't want to say that whole big mouthful. They are based in Champaign. They do a range of training. I think during COVID, they've moved to more virtual training. I think they're moving back to having some more in-person events in Chicago and the Chicago area. But it's a balance, but they do have a lot of online resources. And then they also support a sort of energy code information hotline, so they can answer questions that you have about specific code or specific provisions, both by email and by phone. So that's a resource that's out there. And then the US Department of Energy does a lot of work to support energy codes at all different levels. At energycodes.gov, that's where you can find ResCheck and ComCheck, those online tools. They also have a number of training things. Again, they're speaking about codes big picture. So if you're doing work in multiple jurisdictions, you're going to get that bigger picture view of energy codes and what's happening and things that might apply to climate zones different than Chicago, or things that might matter other places in the country based on differences in climate. They also support something that's out there that I think is a good tool that maybe people don't know about, called the Building America Solution Center. That's a website, again, supported by the Department of Energy and the Pacific Northwest National Laboratory, that has some specific things about different wall sections, different conditions that might be challenging to build, and it has some analysis about building science and some ideas about how to comply in a meaningful way. So that's a resource that's out there that has some good answers to questions you might have. So just some final thoughts before I turn it over to Emily. Again, it's worth recognizing, I think, that Chicago's had energy codes for about 20 years. And during that time, number of model code cycles, starting with the sort of 2000 model codes, there's been significant progress in that 20-year period in what the model code is able to achieve and what industry is able to build to. So again, a building built to the minimum codes when Chicago adopted its first model energy code 20 years ago, building built to the minimum requirements of code today, residentially is 36% less energy usage. And on the commercial side, 45% less energy usage. So making progress, there's still a way to go, but I think it makes sense to recognize where we've come from. And then I think the other thing to recognize is that there are some other factors out there. So we have electrification readiness. People are going to have to make a choice about whether they choose to do gas appliances with electrification readiness or go all electric if the equipment is there. We know there's a number of factors, supply chain issues, market acceptance, things like that. But again, utility pricing is going to be a factor there. So we can see that historically, Chicago electricity was a little bit higher than the national price, and it has come down to below that. Whereas, historically, Chicago gas prices per therm were cheaper, and they're going up. And I think there's been news coverage in the last week or two that People's Gas is seeking a pretty significant rate hike for the next period of time. So I think, again, there are some market forces here too that play into the energy issues, the climate issues, whether products are available, lead times on things to take into account. So again, these graphs show May, which was sort of the last data information before this was introduced to City Council about where that was going. And then November data, the most recently available data shows that it's just moving further in that direction in terms of things. So I'll just remind people for the Q&A, please use Slido, you can join that. And I'm going to turn this over to Emily Purcell with SCB to talk about some specific things that she's hearing from architects.
Right. Hello, everyone. So yeah, I'm here to basically show us some highlights for architects, different from highlights for children. I will try to use some simple words and pretty pictures to get some of this across. So my firm, Solomon Cordwell Buenz, are working on projects of a big variety of scales and program types across the city of Chicago. So really what I'm going to talk about today basically all falls under the commercial side of the code, or as Grant described it, in the everything else. But I've been hearing a lot of different questions and concerns from the project teams I'm working with, and that's what's going to be reflected here. I'm not going to try to be comprehensive about what's in the code. I think Grant, basically kind of covered here's everything. I'm going to pull out a few things that have been especially interesting to us as we start using the new code. So number one question I've gotten is really just, okay, how do I actually navigate through this? How do I know what applies to my building? Which path is which? So all commercial projects in Chicago, which as Grant said is basically everything but our residential 4 stories and under, will come under the 2022 Chicago Energy Transformation Code commercial provisions. So this code establishes 4 compliance paths. Within those compliance paths, the first 2 options are the IECC 2021 with Chicago amendments, or ASHRAE 90.1 2019. There are 2 alternative compliance paths, which are third-party certifications. So that's your Passive House and your NGBS Gold or Emerald level. Won't get into the 2 third-party certifications today. Those are totally separate, and they have kind of on-site verification, but we'll talk through what's going on within ICC and ASHRAE. And within ICC, we have some Chicago-specific amendments. If you follow ASHRAE or either of the third-party certifications, the alternative compliance paths, you will not encounter those Chicago amendments. And then within either IECC or ASHRAE, you're first going to follow all mandatory requirements. These moved around a little bit, admitted like where they show up within the code in this new edition. So that may be a little bit different from past versions, but follow all mandatory requirements and then select either a prescriptive path where you're simply following all code provisions, or a performance path where you are comparing your building's modeled energy use to a prescriptive building. But as you probably saw, the dates for this approach, that was the end of last year. As of January 1st, we've added Chapter 6 of the Chicago Energy Transformation Code. It's simply a kind of middle step between, here's the code that applies to my building and here's the compliance path I'm taking. That's where all that energy transformation lives. This is why we call it the Energy Transformation Code rather than just the Energy Conservation Codes we have in the past. This is where some Chicago-specific energy transformation provisions are found. These are what the City of Chicago has decided are its priorities for either some deeper energy conservation or some transformation in how we supply energy to our buildings. And these reflect Chicago's climate and the City of Chicago's priorities for decarbonization, as Grant spoke about. So first of all, I'm going to dig a little bit deeper into Chapter 6 here, because this is, as I said, this is where the transformation really is. So there's 6 code items within Chapter 6. They're all related to either that kind of deeper energy efficiency or with transitioning away from the use of fossil fuels within our buildings. The first up is solar ready roofs, 603. This basically tells us that for our buildings that are 60 feet tall or less with a ground footprint over 7,500 square feet that need to have some 40% of the available roof area dedicated to solar ready zone. They also need to have structural support and space for future conduit to support future solar infrastructure. Say 40% of the available roof area, that is different from 40% of the total roof area. So it's a pretty common question I've got. So in this example building here, we've got some equipment space, we've got some green roof space. The rest of it is available roof area. So you'd have to take 40% of that for a solar ready zone. So again, very common question, just what roof area am I actually looking at to determine what my solar ready space needs to be? It is only the available roof area. So that raises the question, what if I don't have any available roof area? What if I've got, it's all skylights, it's all green roof, it's all occupied roof deck. 40% of 0 is 0. So you do not have to provide a solar ready zone in this case. So design implications of this, I think the question there really is, what's the best use of your roof? The city's not telling you that you have to do a solar ready zone. The city's not trying to discourage green roofs by telling you to put solar space there instead. So maybe for that warehouse example, a solar ready zone or skylights is the best use. Maybe for a residential project, it's actually going to be a green roof and take advantage of those insulation and stormwater benefits. And the next up under Chapter 6, 604, electrification ready residences. This is definitely an interesting one, definitely new for Chicago. First, it's really, much less cost, much less effort to build all electric now than to renovate to all electric, build a gas powered building now and renovate to all electric in the future. So this piece of the code, it's really trying to give, really trying to future proof and put a much smaller cost up front on the builder rather than a much larger cost on that future owner or tenant. Essentially, this code language says that if you are building a residential unit with gas-powered appliances, you'll need to also provide electric infrastructure for basically to support the all-electric equivalent of that gas equipment. Biggest point of confusion I've heard here is what exactly does this apply to? Which pieces of equipment, which space is the building? So I'll break that down. Within a unit, if you are providing a gas hot water heater, stove, or dryer, that needs to have electric infrastructure. Same with a shared kitchen. So for example, in a dormitory or some kind of shared housing situation, if you have like a community kitchen, that would need to be either an electric stove or a gas stove with electric infrastructure. Does not apply to fireplaces, fire pits, or grills on a kind of shared patio or amenity area, or even within units. Does not apply to a central laundry dryer. So if you have a shared laundry room, you do not need to provide all electric drying. And Grant mentioned, central building systems. So if you have central heating or hot water, that also does not need to be all electric or all electric ready. And anything within your commercial tenant spaces. So pretty common question is, well, what about commercial food service equipment? That also does not need to be electric or electric ready at this point. So as far as the design implications we're thinking through, I mean, the main one really is that it becomes very expensive to build a residential unit with gas-powered appliances. You're basically having to build some redundant systems. So at this point, it's really kind of pushing us to electric, where Chapter 6 requires electric ready. And then second, just kind of make it, link it back to the bigger point about energy transformation. I realized if we're kind of looking at this, it looks like most things are still powered by gas. We kind of maybe we want to take away from this, like, oh yeah, we can still get away with using gas as much as possible in a lot of these building systems. Not a whole lot's going to change. But, I do want to remind everyone there is a nationwide trend toward all electric building codes and regulations. There is quite a bit going on in our clients' worlds as well with their ESG targets, healthy building movement, resiliency. So maybe some of those goals on your client's end don't really line up with bringing in a flammable gas that produces greenhouse gases and contributes to childhood asthma. So maybe the code right now is not telling us we need to go all electric. Don't want anyone to panic and say, oh my gosh, we got to redesign everything right now. Don't want to speculate too much about what's coming next, but definitely want to emphasize that we're talking today about the code. We're talking about the least decarbonized building that you can legally build in Chicago, talking about setting the stage for a bigger transformation in the near future. So moving on from gas versus electric, let's talk about our exterior balconies and parapets. This is kind of a new one for a lot of us in Chicago to have these be continuously insulated or thermally broken. And that's really the big question I've been hearing about. That is like, okay, what do we do here? What does this actually require? Has anyone been doing this elsewhere in the country? How do we know what our details need to look like? One great source for that, of course, is manufacturers, insulation, as well as thermally broken structural components. There's quite a bit of resources out there if you have a project and have a manufacturer you can go to. But also want to point out our language in this code is pretty much identical to New York City's 2020 energy code. If you just search for like New York City energy code parapets, you'll find this diagram and a few others. So definitely recommend looking up some of their resources, or if any of you work for a firm that also has work in New York City, that may be a resource you can find in-house. So I think as this becomes a little more mainstream practice here in Chicago as well, we'll start building up those resources locally. But for now, that's the real point. Yeah, go look for some New York projects and speak to their manufacturers. Right, and the last three items in chapter 6, all pretty straightforward, and Grant spoke to them as well, so no new gaslighting. Then 607 and 608 both just point you to other codes where they are already required in Chicago, and if you have built a project in the last couple of years, you've already complied with the cool roof and the EV ready ordinances. All right, so let's zoom back out to our overall process here. If you remember this little diagram I showed you a minute ago, are going into our compliance paths. So the first option here is just the IECC with Chicago amendments, either performance or prescriptive, and we're following all the mandatory requirements. This is one of our Chicago amendments in the IECC. It's going to apply either to the prescriptive path or it's going to apply to your baseline building if you're following the performance path, and that's about fenestration orientation. So where are we putting the glass in our buildings? What is the performance of that glass that we're putting on our buildings? How do we do this in a smart way for energy consumption? So really what we're trying to avoid here is a building like this example that's really elongated north to south and has a big piece of glass on the western face on a hot summer afternoon, or as our climate warms up here, maybe a hot fall or spring afternoon. You get quite a bit of solar heat gain on that west face. You rely a lot more on mechanical cooling. So this is really just trying to go to passive methods first before you start having to lean too hard on mechanical system efficiencies to make up for that solar heat gain. So the code gives us this page of equations here to figure out how we're going to do that. And I don't know if it's anyone else intimidated by this when they see it. When I started looking through the code, I was like, all right, I'll come back to this later. But once I did come back to it, though, it was definitely a lot easier to break down. So I'll kind of give you some pointers in that direction. One thing that really helped me understand this personally was just putting them into Excel and putting in some kind of imaginary numbers for imaginary buildings. And that really helped kind of make it digestible and break it down. So that's one recommendation I'll start with, just to grab some of these equations, start playing with them. It becomes a lot easier than it looks right here. So just to start breaking them down for you today, first of all, it tells us you have to comply with either 4.3a and 4.3b or 4.3c and 4.3d. So comply with a set of 2 of these. And what are those sets of 2? Each one is a set of east and west. A and B give you a couple of variables that you want to compare, and then C and D add some more. So, all right, what do these actually mean when you put them on a building? And this is how you can tell I'm not an architect, because I'm totally okay with how the windows look on that little cube I made in PowerPoint. So kind of made this, here's this imaginary little cube building. It's got 1,000 square feet of glass on each side, totally equal. Put it into my calculator here, and they both passed the first 2 equations, A and B, because the glass on the east and west faces is not larger than a quarter of the total amount of glass. Let's say I wanted to expand those windows on the west face and maybe reduce them on the north and south. So now I'm a little off balance. I'm putting on 1,200 square feet of glass on each face on the east and west faces. So that does not pass these equations. Those faces are larger than a quarter of the total amount of glass. So I'd no longer pass that first set of equations. I need to move to the second. How am I going to do that and still comply with the energy code? I'm going to mess with the solar heat gain coefficient of this glass. I'm going to put some much higher performing glass here. I'm going to bring that solar heat gain coefficient down from the code maximum down to 0.25, make it some dark glass. Now it's going to pass 4.3c and 4.3d. Because that gives you kind of a weighted performance value for the whole building. So don't worry too much about the specific numbers. Like I said, the best thing to do is really to start playing with some of these equations yourself, and you'll start seeing how they affect buildings. But just want to get through, what are the design implications here? Complying with that weighted solar heat gain got really hard really quickly. Like I had to go down to 0.25 to make that kind of relatively small increase in east and west facing glass work. it's definitely played out that way for some of our projects as well that are really north-south elongated. We're finding that there's just no high performing enough glass on the solar heat gain front that we're willing to use on those buildings to meet these equations. So if you have a relatively square building, I would say definitely better just to balance your glass and opaque area on those east and west faces. If you do have one of those more north-south elongated buildings, that really just pushes you to the performance method. This is a prescriptive requirement. We're finding that projects we had that maybe used to be able to get by with the prescriptive approach need to go to performance now because of this orientation requirement. So they're going to be comparing themselves to a compliant baseline building rather than just simply complying. And then related to that, there is an update in this version of the IECC. You all might recognize this table just from looking up your required U factors for glass. IECC used to break those down by orientation. It no longer does. Now it is just by fixed and operable. And the great thing about this update is it is consistent with ASHRAE 90.1. So you're no longer looking at two really different sets of factors for your fenestration products. You are looking at two base. I think they're almost entirely identical, if not totally identical at this point. The tables within IECC and then within ASHRAE. So that is a nice change to just keep everything consistent there and break orientation out into a separate requirement. All right, and then this is a pretty minor IECC update, but it's one that I get questions about all the time. So I'm going to throw it in here on roof insulation. The question is, if you're using tapered roof insulation that gets narrower as it goes down to a drain or a gutter, how do you decide what the R value is? It's a different R value at every thickness. So how do we know what it is? IECC had some different guidance on this last year. They updated it this year. Now they tell us at that lowest point at a roof drain or a gutter, that needs to be minimum 1 inch thick. And then you take your R value at the average thickness. So again, not a huge deal, but one that has thrown a lot of folks off in my experience. So I just want to add that in here as well. And just to be clear, also, this is not Chicago specific. This is part of the IECC 2021 that Chicago's code is based on. And this is also different from ASHRAE 90.1 2019. ASHRAE tells you need to meet your minimum R value at the lowest point. So that's definitely a difference between the two codes, as much as they have kind of converged over the last couple updates and become much more consistent. That is one difference in how they handle this type of product. All right, so zooming back out to our flow chart, let's look at the second compliance path here, ASHRAE. I'm actually not going to get into too much detail about ASHRAE just because, as I said a minute ago, ASHRAE and IECC have become very similar, very consistent in the last couple of updates. So we don't have a ton of really notable differences between the two. But I do want to bring up one thing that is new in both ASHRAE and IECC. Whole building air leakage testing is now mandatory for basically for all projects. Won't get into a ton of detail here either, partly just because it's not my expertise and I don't want to say anything wrong, but also because this can get very project specific. So definitely recommend taking a look at the code language in both ASHRAE and IECC. If you are working on a large project, you have an enclosure consultant or a blower door testing provider, definitely reach out to them. They'll have all kinds of great project specific advice on this. Just as some very general implications that I think are important for everyone to know. This basically used to be your compliance used to be determined through design only. Now it is determined via on-site verification. So you'll need to make sure you're detailing your air barriers, make sure they're buildable, make sure that your contractor understands where the air barrier is and that it will be tested for performance. And also coordinate your on-site testing with your contractor. This can add time. You will need to make sure it's happening at the right point in the construction schedule. So work with those consultants, work with those contractors, and make sure you are getting those details down, as well as coordinating your schedule for on-site testing. This is new. This is definitely going to be a bit of a change, especially on the building side as we work through those schedules. All right, and that's everything I've got. We will move into some discussion.
Thank you, Emily and Grant, and thank you for everyone using the Slido and participating actively. There are 16 or so questions in the Slido right now, which I'm going to put up here on the next slide. So if you see one in there already that you want to make sure that I ask, make sure to put a thumbs up on it because it'll bring it to the top. But also, we'll go around with we can ask questions from the audience too as we get into it. If there's anything that we don't get to, or if it didn't get a thumbs up, but it still is a valid question, I think that everyone would be totally willing to answer those questions after the fact, and we could send it back out to everybody so you have the answers to the questions that we don't get to as well, or might be just specific to an individual project. But I mean, I guess the number one question probably was, will we get this presentation afterwards? Which just about everyone thumbs up. And I think it's we're going to be able to send out a presentation afterwards. They'll be online later. That date is TBD, but I just want to say it out loud in case you didn't notice on the Slido or didn't see the answer to that question there. And we did put together some facilitated questions. We talked about it last week, but you guys have all asked the facilitated questions that I was going to ask. So good job thinking of the questions we already thought of. And so I'm just going to jump right into those and get that out of the way. I think one of the big ones is that Grant touched on it and Emily touched on it as well, is the electrification readiness of all new residences does not include electric ready for HVAC. And so there's a reason why that wasn't there. And I'm going to throw it over to you guys about the amount of power it takes to switch out HVAC equipment versus some of these other things. So I don't know, I'm going to go to Saagar first because you haven't answered anything yet. Can you switch out some HVAC equipment without making it electric ready in the code?
Not easily, right? So the justification, at least Grant at least alluded to before, is when it's a much easier transition when it comes to our stoves and like dryers and all those fun things. But when it comes to HVAC, it's a lot more challenging and a lot more electrical power to go to electric resistance heat, right? And even then the building envelope has to meet those requirements. And so it's the bigger lift to be able to get that electricness ready versus all the other equipment. You just don't need as much electrical power to make that conversion.
Was there another reason why we didn't address that in this particular version of the code?
Yeah, I think that, again, one thing that the city council passed as a separate ordinance last summer, and I think everyone was building this anyways, so it didn't get a lot of attention, is new residential now requires air conditioning. So to put in air conditioning, almost all air conditioning, probably all of it in Chicago is electric powered. So there's that electrical capacity for the cooling load, meeting that. And I think with new efficient heat pump technology that can do both cooling and heating, that capacity is either there now with current technology or is going to be there when that building needs to convert to or wants to convert in the future to all electric heating and cooling. It's not the same as for the other appliances that are covered by the electrification readiness.
Awesome. Something related. So I'm just going to keep going with this one. Does electric ready and new construction require the building to have the electrical service for the total load at the time of construction?
Yes.
11 people wanted to know that answer, so I hope everyone heard. And then another good one around the buildings and the solar ready. A lot of people did a thumbs up to this one. If the building is shaded by surrounding tall buildings, do we still need to prepare for solar on the roof?
So there are some exceptions for shaded roof area. They get pretty in the weeds, but a design professional would have to certify that condition exists in terms of the shading. But there are exceptions written in that take that into account.
Has that come across in any projects that you've looked at yet, Emily?
Hasn't come across yet. The projects that we have worked on thus far that fall under that solar ready requirement of being under 60 feet tall are also not in kind of the downtown area where you might have much taller buildings shading them. But yeah, those exceptions are there. Yeah, if you're a design professional who has done maybe a shadow study or any other kind of support for that building not being able to really functionally use solar power, that is another exception that we're glad is there.
There's another question that is getting a lot of likes too. It's a specific one. So if we need to answer it later, that's totally fine. But thermally broken or insulated balcony as defined in Chapter 6 is fully mandatory, correct? And cannot be offset by performance via energy model.
That's right. Yeah, it's kind of walked through that process slide a few times, but that's in Chapter 6, which shows up before you branch out into any of the prescriptive versus performance paths.
Awesome. I like this slide or this app, but it's moving questions around. So let me sneak back to the one I was just looking at. Residential roof tear-offs down to sheathing, do they need replacement to R60?
Yeah, so this is where Chicago has had its own sort of specific language different than the state's language, I think for the last 2 or 3 code cycles, and that's stayed. So if you have a tear-off condition of an existing low slope roof and you have to replace it, but there are obstacles in terms of sill heights for door openings or flashing or equipment that's already there, you are allowed to only replace it back to the sort of maximum depth you can do without changing any of those things. There is a minimum R value per inch for that insulation you're putting back, and you can't make it worse than it was. But that is sort of negotiated roofing industry, other stakeholder language that's been in Chicago for a while, and it has stayed. So it is still in this code.
I'm going to improv for a minute off of that question. I feel like there were a lot of conversations at the state level around the IECC 2021 and this roof component in particular. Do the things that are happening in the Chicago code help?
So for the last iteration, they took the Chicago definition, but it became a little bit challenging because then we had to redefine a lot of what we were defining as re-roofing within the IECC at the state level, which then became a very political discussion around should we be carrying definitions. Then as next iteration, I believe we kind of cleaned up the language to match a little bit closer and be more clear on exactly when you're taking off, which level, when you are taking off the roof and replacing it, when do you actually just replace it like for like versus when do you have to actually meet the energy code. It's definitely something that outside of Chicago is definitely a lot of gray area that, we wanted to clean up on the definition side.
I remember lots and lots of conversations about that went on for hours. So a big hot topic. So good that all of your questions are reflecting everyone else's questions around roofs. There's another one around R60 that I'm just going to jump really quick because it has 10 likes also. And now it moved. Nope, it moved. Oh, for R60 roof attic insulation, can it be split between CI above deck and cavity insulation in a truss space? Anybody?
That's a very specific question. There are sort of
Michelle, very specific.
There are some trade-offs for roofing, just like there are for walls. I would say the walls are better spelled out in the table, and that trade-off between continuous and cavity insulation. For the sort of roof and attic conditions, it's more in the text below the table. And I didn't memorize that or have a copy right now.
Don't worry, we can get back to it later. Does a couple of questions around kind of the inspection and self-certification process? That's okay? Yeah. So does the self-certification process get affected by this, paperwork, submittals, et cetera?
Yes. So again, right now, as if you are a project that started the permit application process by paying the permit deposit fee, since November 1st. We've had new forms out online. I think that an email went out to everyone right around that time saying that those new forms were out there, but you can find those forms chicago.gov/permit for the forms page, or chicago.gov/energy code links to those. So you should be, if you are doing a project that started since November 1st, using the updated form. It looks very similar to the old form. Some project managers and project administrators are going to send it back to you if you have the old form. And then, as I mentioned, the sort of PDF forms, probably in the next month, we will have the online interactive tool to complete that same type of information. So probably the PDF forms will be phased out sometime this summer as we make sure that that tool is 100% working. So self-certified, standard plan review, developer services, all projects have to do that one-page compliance statement. And they should be doing the compliance statement for the correct code version.
A couple other relation to inspection and permits. I'm going to combine these two because I think they're both for you, Grant. Is there an inspection component to the energy transformation code through the Department of Buildings? And separately but related, is permitting required for PV outside of the building permit?
Yeah, so for the first one, in the last probably 4 editions of the energy code, at least, there has been some amount of testing and verification that is supposed to be done. And Chicago has usually amended the energy code to say that the model energy code says you have to file proof of that with the department. We don't have a system for that, and we don't really want to receive that paperwork. So it says that it has to be made available to the building official. So some of the inspectors will ask for it, especially if they see a really badly insulated or badly installed mechanical system. They can ask to see that testing and verification paperwork. It is an obligation that's out there. As I think I mentioned in my presentation, something we've had on that compliance statement for the last, I think for the last 2 versions of it, is an obligation to inform your clients of the obligation to do the type of testing based on your project. So it's an obligation on owners. It's something that inspectors do audit, ask for. Not every project. I would not say not even most projects, but they do have the ability to ask for it, and a project will get held up from final approval or certificate of occupancy if that hasn't been done and it is supposed to be done. So doesn't come up all that often, but it is an obligation that's in the code. It's an obligation that design professionals should be informing the owner, and hopefully the construction team, if they're on board, is going to come up. And then sometimes it does hold up projects if they choose not to comply after all of those warnings at the permitting stage. The second question was about PV permitting. So again, if you're installing it as part of an overall building permit, it can be part of that overall building permit submission. We have something called Solar Express for adding solar PV to an existing, mostly residential building, small scale building. That process will be getting revamped this summer as we move all of our sort of easy permits, express permits to a new process. So there will be a hopefully slightly streamlined version of that that is coming out. If you are adding solar PV, solar photovoltaic to some other type of building, it is a project that does require plans. A lot of people like to wish that there was some other process, but we have not come up with one for now that is some express no plan review process for adding solar to some other type of existing building. So it can be integrated with the building permit. It doesn't need to be a standalone permit like fire alarm systems or sprinklers or elevators. We do have standalone permits to do it if you are retrofitting on, easier if it's a small sort of residential scaled building, harder if you are doing a larger PV installation in that it requires, full design, and there are some structural implications to add it to an existing building.
I think this one is related to solar also, and kind of hits on something Emily talked about earlier regarding the roof area for green roof versus solar and that available roof space. And it just moved. Here it is. Okay, here's again. Is regarding the roof area available for solar. would a pledge to install solar in the future take precedence over a requirement for installing green roofs on a certain square footage?
That's a great question. I guess it depends where that requirement for green roof is coming from. Chicago has the cool roof requirement, which is a little different from green specifically. That's just about the reflectivity of the roof surface. Green roof would also comply. But the energy code does not require green roofs in any way. The energy code requires that solar roof area set aside out of your available roof area. So if you are receiving a requirement for green roofs from somewhere else, that would be a question for that authority.
Yeah, I would say sometimes there are requirements for green roofs negotiated into individual plan developments or as part of the sustainable development policy. So that would be a question for DPD or your zoning attorney if it's coming from that process.
Here's a really specific one, but it's getting a lot of likes, so I'm going to ask it anyways. We have a rehab project ready for uploading for permit, 2-unit residence. Does it have to meet the electrical ready furnace or hot water heaters? They were not obviously planned as drawn.
So again, the sort of when a permit application is started, the policy that we've used for all of the code transitions that I've been here for is when that deposit fee is paid. So it's not about uploading. It's when the $300 building deposit plus $75 usually zoning deposit is paid through the online interface, or you can pay at a cashier. So if that was paid before January 1st, you are before that requirement. If you say you're sort of ready for uploading, but you haven't paid that fee yet, you're paying it today, you're under the requirement for electrification ready residences.
And how does the code address battery storage, and is permitting required? And is it part of the energy code here?
Yeah, so again, battery storage, there's some fire prevention provisions around that in the 2019 package of codes that were adopted. That is one chapter that was adopted from the International Fire Code as part of the sort of interim fire prevention code. So that is out there as ordinance. In the 2021 International Fire Code, they rewrote all of that. So I know the fire department is looking at that and will have discussions about that on an individual project basis. And I think we're expecting in a near future, hopefully code modernization phase, the fire department will be looking at their codes again. But we do recognize right now the code around especially larger battery systems is evolving. It would be an expectation if you're putting any kind of large scale battery in that you get that permitted. If it's a small enough scale battery that it's integrated with a solar PV system that's installed under Solar Express, that really doesn't have, those are small enough batteries. So the sort of Tesla wall pack residential home scale batteries not implicated by this, but larger battery systems for larger installations, the code is evolving. There are fire protection requirements. We have adopted largely the 2018 model requirements for that in Chicago. But again, new area, rapidly evolving, newer model codes, very different than what we've adopted. So if you have a specific project with larger battery installation, that's something to have a meeting with both the building department and the fire prevention bureau about.
Awesome.
And then I think the solar ready zone does also require space for future batteries. That's correct, right? No, maybe.
That's a maybe. I know it
Okay.
has space for sort of transformer equipment. I don't think it requires a battery, but
I guess we need to do a little more, do more homework.
So today's presentation has been mostly about making sure we understand the current code. So I saved some of these questions to the end that are more about future policy and what's coming next. So we have a couple minutes left. I'm going to just ask a quick fire question that's not a quick answer about, should we expect properties built for compliance with older codes to be receiving pressure to retrofit their buildings to move Chicago towards climate goals in the near future? And I would say, based on the recommendation report from the building decarbonization working group, there are some recommendations in there around existing buildings. I don't know if anyone wants to address some of those conversations.
I'll start because that is a hard question.
Mhm.
But so again, there is a national movement. The city has made a commitment through the White House to be in a working group studying this. Some other cities are maybe further ahead on this road than we are to have something called building performance standards. It's a nice framework name, but they look very different everywhere they're implemented because, again, they have to be responsive to existing building stock, which is very different between Boston and St. Louis and New York City and Chicago. So again, to the extent there is going to be a requirement for existing buildings, we've had benchmarking for a while for our larger buildings, 50,000 square feet and up in terms of existing building stock. And I don't, do you know how long we've had benchmarking? It's probably
2013.
2013. So a decade this year. Those buildings have made a lot of voluntary improvements, just sort of having that data, seeing that they were in the bottom tier of comparable buildings. So for that part of the building stock, there's been voluntary improvement, and different building performance standards have a different range of sort of mandatory. I'd say that's certainly an idea that's out there that's being discussed and studied for Chicago. It's a long way from legislation, but this is all moving fast. I would say electrification was a long way from legislation 2 years ago. So.
May also throw in within the IECC, even 2021, there's the existing building chapter that is getting tighter and more restrictive, and isn't what's going to trigger. And when that trigger, what kind of projects will trigger updating all your equipment, updating your envelope and things along that line. So the existing building is one chapter is an element that we can use. In addition, you also have some of the elements coming through CEJA, right? With the various phase outs and the increase in different PV readiness and all these things and all the money available, there's going to be pressure to update your building just because you may not have fossil fuels available to you by 2045, I think is the cutoff, right? So at that point, you got to start future proofing your buildings just because out of necessity.
Mm-hmm.
And so that's kind of, right, there's always the leaders and then the laggards, and we're trying to have the codes push the laggards, but there's going to be market pressure to at least get them up there as well.
Yeah, I'd also say in addition to pressure on those buildings to bring up their performance to current standards, it also say incentives and opportunities, not just a kind of negative word, but some positive ones as well. We're definitely seeing in CEJA, the Climate and Equitable Jobs Act in Illinois that's recently passed, and the Inflation Reduction Act, like quite a bit of funding and other opportunities for bringing up the performance of existing buildings, doing energy benchmarking, retro commissioning, all kinds of work to bring those in line with a more energy efficient and electrification ready near future.
Wonderful. And I know that I'm 2 minutes over, Joan, but we did start 5 minutes late. And so I wanted to just acknowledge that there's 34 questions in the Slido, and I did not get to ask that many. And so if I didn't get to your question, it's not because it wasn't an awesome one, but I promise that we'll work with the speakers and get some answers to those additional questions and maybe make some sort of fun FAQ document that goes with this presentation. So thank you everyone for all of your questions. And we'll be following up with some more details afterwards. Thank you to all of our panelists for telling you everything about the Energy Transformation Code. For those that are willing to stay, I hope lots of them are. Doug Farr is in the back. He's going to tell you for a couple minutes up here in a second all about the Energy Transformation or Energy Revolution exhibit. Sorry, I'm talking about Energy Transformation Code. And I want to just thank AIA, Chicago, and CAC again for hosting us today. So thank you very much. I'm going to turn over to Doug to say a couple of things. Oh, and there's a thank you slide. Perfect. Thanks, Grant.